Yes. Then next one, the 16th one. In this case, it is related to the preparation of alkene. Um, this is how you can do it. The 16th one, the 16th question says that you have CH3, CH2, and OH. And we need that the CH2 double bond of CH2. Then now you can do it. You can just add, there are two methods of doing this, easy methods. One is the addition of concentrated conc H2SO4. And in the real case, we have to heat that up to 170 degrees Celsius. But in exam, if you just write the heating, that is enough. You can use this. Or you can use the alumina. Alumina means Al2O3. If you use that Al2O3, normally we write it as delta, means you have to heat it. But in real case, you have to heat that up to 350 degrees Celsius. Right? If you heat that up to 350 degrees Celsius, then you can get this product. So this is called elimination reaction. That means how this really happen. Maybe when you have that the CH3 can be written like this, H and H, then it is bonded with the hydrogen, and then here you have that OH group. Then the OH will be attached with hydrogen on the next carbon, and give us the product like this by removing the water molecule. So these are called the dehydration agent. This was sulfuric, concentrated sulfuric, and this alumina, Al2O3, considered as dehydration agents. Here, if you have two different carbon like this, say you have one having three hydrogen attached to that, as the neighboring carbon, or you may have hydrogen having like this. Then here you have another hydrogen, and here you have hydrogen and hydrogen and hydrogen. So in this case, when we add this, say Al2O3 and heat it, actually you will get two products by removing hydrogen from this carbon and by removing hydrogen from the other carbon like this. In such case, the major product will be given according to some rule. That rule says when water or HX removed, when especially the high, in this case, in our case, when the water molecule is eliminated from a given organic compound, the OH will get hydrogen from the nearest carbon. That is okay. Maybe from this carbon, no that carbon, maybe from one, no two carbon. But that law says, Zaitsev rule, that is called the, the Zaitsev rule. According to that, it says the OH will go with the hydrogen on the near adjacent carbon having the lesser number of hydrogen. That means this may be the removal of hydrogen from the second carbon will be the major product. So here you will have CH3, then CH and a double bond and CH and another CH3. So this will be the major product. Major product according to Zaitsev rule. Say it's a rule. And there may be another product that is called the minor product. That is the CH2 double bond CH and CH2 and CH3. This minor product. If the yield here is 70%, this may be 30%. I don't know exact numbers, but I just told you there may be difference in the product, the amounts of product you obtain. So here also you add alumina O, conc, H2SO4 and heating. One of them, right? One of them, alumina O, sulfuric can be used in this case to remove a water molecule. Now the rule behind this one is called the Zaitsev rule. Elimination work with that Zaitsev. So this is our 16th yeah, just explanation about the Zaitsev rule. Then the 17th one. Maybe like this. Right? Here, this must be 3. Right? Not 2. CH3, CH and CH3. Then both of the sides are same. Therefore, removal of hydrogen from any carbon may be same. So you will get with this. Then you will be wonder what will happen if this is the product. Actually, both of these products are same. You can write down the IUPAC names. Then you will see that the names of both these compounds are same. Names of both of these compounds are same. Therefore, you'll get it. Right. This next one will be the 18th one. Again, removal of HX. That is removal of HX. Earlier one was removal of water molecule. Now the removal of HX. HX means the removal of this HCl, HBROHI. Then again, this chlorine bromine iodine will be removed by giving hydrogen atom to that in the same way, but in this case you have to use alcoholic KOH. Alcoholic KOH, and sometimes you have to heat it, then you will get this product state. In this case also, that Zaitsev rule will work with that. But if you have two possible hydrogen atoms which can be removed in the preparation of this alkene using alcoholic KOH, then say you have the OH group here, then you have hydrogen, 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 and here hydrogen, here may be hydrogen, here also hydrogen, here may be hydrogen, here hydrogen, and hydrogen. Then this OH has two options. Then remember that whenever they give hydrogen, always that hydrogen will be given to the carbon having higher number of carbon atoms. When we remove, it removes from the carbon having low number of carbon. So that will be the major product, and also the other product will be available as the minor product. එතකොට මෙතනින් මොකක්ද වෙන්නේ? You have to add in such a case. Say you have bromine or chlorine or whatever, say bromine, then this bromine can go with this or go with this hydrogen. So there are two products. I can write down CH2 double bond CH and CH. Yes, like this. Right. Also, this will be the minor product. This is minor product. So what will be the major product? Major product is the product to obtain by removing hydrogen from the adjacent carbon having lesser number of hydrogen. In this case, you have only two hydrogen. So removal of hydrogen will be from this and then get the product. So that is called the major product according to then alcoholic KOH. Right? That is the and the 20th part. Again, the same thing as I told you here. You can remove hydrogen from any of the carbon from any side, but still the IUPAC name will be same. Therefore, I can straight away remove this by adding alcoholic KOH and heating. That's all. Alcoholic KOH and heat. Then the chlorine will go with one of the hydrogen from adjacent. Then the 20th one. Okay. The 19th one, that's the 20th one. That's nice one, but it's I can't copy it, so I will write it. They are asking what is the product if you add something like this, say the CH3, see how you can give this. Here you have that chlorine. Yes, just look at that in yours. So it is bromine, no? But sorry, there is bromine. Then what happens? Yes. But here again, you can easily use the alcoholic KOH is added, then you will get this CH2, CH2. Then you will get that according to that rule. So here you can use alcoholic KOH and heating. Right. This is the product. You can try. Then the reactions of this alkane. Um, in the case of this 21 Puta, actually you can't do it because it is car. Because you don't have the carbon having hydrogen atoms of the adjacent. They asked about this, how to do this. As you can't do it, why we can't do it? We had a bromine, but bromine cannot grow with hydrogen on the adjacent carbon, but on the adjacent carbon, Then you can try the next 20 seconds. Mhm. Again, there's a problem with this highlighting of this. Then anyhow, I will try it this way. Yes. Um, this one we will try, right? I can get this content like this and then paste here. This one, right? Starting from this, this is called the eti. From making, you have to obtain 1, 2, 3, 4, and 5 products. Right now, you can try. Himbalan, this is actually not in our syllabus, so you can skip it. Right? This is you can skip it. Actually, for that you can add Br sodium bromide and this sodium hydroxide, something like that. Then Br2 sodium bro. So you will get it, and it is not needed in our case. And next one, yes, you can just add the H2 nickel. Then you can remove the pi bond and add two hydrogen atoms to that. Right? If you add just H2 nickel, then you will get this. That means the pi bond can be substitute. Pi bond will be a, and then you will add two hydrogen atoms to that. And here to here, you can just add that Br2 CCl4. That is the much popular method of doing that. Right, most popular method of doing that. Here to here, you can, yes, you can get this D. How? First, you have to get this product and find get this. Then what will happen? You have to add here. I will extend this. First, you have to do this, and then I extend it. You will get CH2, CH2, AMGBr. Then here you have that magnesium and Br. Here also magnesium and Br. Then you can add D2 like this. Next one, again no need to do that. That is not in syllabus. So you will get these simple reactions. These are all very simple conversions. Even in the exam, you will get these reactions. Right. Another 23rd one. In this case, you are asked to get the get two different products. Here to here, this is addition of HX. That means HCl, HBr, HIO, water molecule. It will first break into the anion and cation. That means hydrogen plus N, the Br minus. So the major product will be this one, major. This is the major product. This is our minor product. Or you can obtain by using two different reagents in this case. So here to here, what you have to add is this is HBr. Yes. Right. Now here to here, this is the minor product. Minor product can be obtained just by interchanging the places here. Here you had a Br, but now the Br has to be moved into the next term. In this case, you have to do it in just at this HBr, but in the presence of organic peroxide. Here you have to use organic peroxide, or at least that hydrogen peroxide that will work with this. That is called anti-Markovnikov rule. That means the position of that will change. Right. That means that normally when you add HBr or HCl or water into alkane, the hydrogen will go with the atom having higher number of hydrogen. See here you have only two hydrogen. So hydrogen will go to the higher number of hydrogen atom having the higher number of hydrogen atoms. So this will be the major product, and this will be the minor product that is automatically given. But if you need it as the major product, then what you have to do is you have to add that the organic peroxide into that, or even hydrogen peroxide will work. Then the 24th one. Any question, problem? Anything you can't understand? Yes. Here, Buddha, remember that if you have any product having the two OH groups or two Br groups of the adjacent atom, that means one on each, then you can try with like this. Make a ganda pull one. Oh, yes, in the other way around. Want make a ganda pull one this CH. About here, you have to have a double bond. Right? Then you can add here alcoholic, sorry, alkaline KMnO4. Here you can use KMnO4 in the basic medium. So that's how you indicate it. KMnO4 slash then the OH minus group. OH minus indicates that the medium is basic. Then you will get the product as shown in this. Two OH groups will be attached to the adjacent atoms. This is the one. Whatever From this you can obtain this. How you can get this? Here you have to remove a water molecule. For that you can use the conc H2SO4. If you use conc H2SO4, then you have to heat that up to 100. Normally we have to heat that up to the 170 degree Celsius. Okay? Then you will get this product easily. Then the 25th one, a bit long but nice. Again, I'm facing on the same problem. How to get it? Mm, yes, like this. Then I can cut it off. I can select it like this and got this. Here is the why is it? Yes, now this one. Right? Here, you have to prepare this in two pathways, and also you have to get this. Means the same product, but in two different ways. This is just to give a recap of reactions. So this will be like this. The how you can get this in two different ways. Here you have to have this CH3 CH2Br. So you can easily remove this just by putting conc H2SO4 and heat it. Then you will get the CH2 double bond CH2. Like this sulfuric and heat or alumina and heat. Here to here, you can just add the HBr. Then you will get this product. Now you have to add first and second. That means first you can add magnesium and dry ether. Second you can add H2 or then you will get this product. And here to here. Right. How you can do it. This is, I told you that you can put this 1 and 2 only for the hydrolysis. Right? But not, you can't combine two different reactions. But in this case, you can use just because it is the Madabe. Yes, hydrolysis process. Then here to here you have that Br. So Br have to convert into OH. For that, you can add just the sodium hydroxide. You can add sodium hydroxide and heat, then you will get this product. And here to here, straight away you have to get this. Here you have double bond, and here you don't have any double bond, means you have to add the H2. So for that, you can use H2 nickel. Then here to here, you can easily obtain the double bond like this. For that, you can use Al2O3, Al2O3 and heat it. This product will be obtained. And so this is very easy. Right. I hope that it's clear. Yes. This one. Nice. Yeah, this can be obtained. I have given you the theory. There are many methods of doing this. I will just use simple one. First you can convert that into CH3, CH2, and OH. Then you can oxidize this by using, that may not have done in the lesson we have done so far, but that is a reaction which we use in our aldehyde and ketone lesson. So here you can adjust the, we have to control of going that into carboxylic. Acid don't heat in, therefore you can adjust the PCC. PCC will give us this. What is it, PCC? PCC is the pyridinium chlorochromate. Then you can easily convert any alcohol, the primary alcohol, into the aldehyde. Next, the 27th. Yeah. You have to have two bromine atoms on the same carbon. That is called the geminal dihalide. If you need geminal dihalide, then you can just add the HBr into this, then you will end up with this kind of a product. Having two halogen atoms on the same carbon, that is called geminal dihalide. In this case, if you add HBr, then you will get this geminal dihalide in this case, right? Again, remember that the hydrogen will go to the carbon having high number of oxygen or the hydrogen atoms in this case. So this carbon will add. Then the 28th one, have done all this, Buddha. Then did you try them? Have done all these things, is that Serena, I think. Yeah, Serena. Yeah. Hmm. For this, you didn't get it. Why I sent you that? But I will send you anyway. Um, Give me a second. I will just send it. mm, and now I am sending that, right? Did you get that? Oh, I sent that. It is on the way. You will get it right now. Right. I think you got it. Right. And the yes, I have to send it to. They know the. Yes, done. Then just I'll give few minutes to try some questions. Here you may try few questions. Here try the question number up to 30, 29, 28, 29, and 20. Sorry, that's 30. No, you may try up to the question number 33. 28 to 33. I'll give you 5 minutes to try it. Right? You have to do by yourself. Up to 23.